Okay, this lesson is on polynomial division. There are actually two types of polynomial division. One way to divide polynomials is using long division. The other way is something called synthetic division, which is kind of a shortcut, but it only applies to certain situations. And so because this first example is already kind of worked out, I'm going to skip to example 2 and show both methods. And so to kind of create an analogy between the long division we've done since elementary school is if I had the number 343 and I'm dividing that by, let's say, 4. We look at the 34 and ask ourselves 4 times what would get us close to 34? And we know 4 times 8 would get us 32. And so we subtract 32 and we end up with 2, and then we just bring down the 3. And then we know 4 times 5 would get us 20. And then we can subtract 20, and that would give us 3. And since 4 doesn't go into 3, that's as far as we can go. And so there's different ways we could write this answer. And so just to put some vocabulary on this 343 is called the dividend. And this 4 is called the divisor. This 85 is called the quotient. And then this 3 left over is called the remainder. And so often we'll write our final answer as the quotient. And then we write the remainder over the divisor. And so the answer to this problem would be 85 3/4. And so we're still going to have these remainders and divisors and dividend or quotients, even when we're working with polynomials. And so here we're dividing 2x to the 4th plus 3x, all of that. This is going to be our dividend. And we're dividing it by x minus 1, which is our divisor. And so we're dividing a degree 4 polynomial because it has an exponent of 4 as its highest exponent. Degree 4 divided by degree 1. And so we set it up just like we would with numbers, 2x to the 4th plus 3x squared. And we're missing our x cubed term. So anytime you're missing a term in your polynomial, you have to write it with 0 as its coefficient. You absolutely have to have these placeholders. Otherwise, you're going to get the wrong answer. Your terms aren't going to line up. And then we are dividing by x minus 1. If I was missing a term in the divisor, I would also need a placeholder. Okay, and so from here, we're just going to focus on the first terms. Each time, you're only going to focus on the first terms. And so we're asking ourselves, x times what would get us close to a 2x form? We should get there exactly. And so x times 2x to the 3rd would get us 2x to the 4th. And so I'm going to put a 2x to the 3rd above that term, and then you're going to multiply each term, the 2x cubed times x, and then 2x cubed times the negative 1. So 2x cubed times x is 2x4, just like we wanted. And then 2x cubed times negative 1 is negative 2x cubed. Since there's 2 terms in the divisor, I'm going to have 2 terms after I multiply. And then, just like with this numerical example, we're going to subtract. And whenever you subtract a polynomial, you are distributing a negative to each term. And so I say, draw the line change all your signs. That's how you distribute a negative, is you end up changing all the signs. And then you can just add down the columns. And so your first term should always cancel out. And then 0 plus 2 gives me 2x cubed. And then you would just bring down the rest of the term. Okay, and so now don't look at anything above this line. Our next term that we're looking at is 2x cubed. And so x times 2x squared would get us a 2x cubed. So now I'm going to take that 2x squared and multiply it by each term in the divisor. So 2x squared times x is the 2x cubed, just like we wanted. And then 2x squared times -1 is negative 2x squared. Draw your line. Change all your signs. First term cancel. Then that leaves me with a 5x squared. Bring down the rest. And so now we're at the 5x squared. And so we're asking ourselves, x times what would give me a 5x squared? And we would need a 5 and an x. So now we're going to take that 5x and multiply it by each term in the divisor. And so 5x times x is the 5x squared, just like we wanted. 5x times -1 is negative 5x. Draw your line. Change all your signs. And so this time our x term ends up canceling out, and then we're just left with a 7 here. And so once you end up with a remainder that's smaller than the degree of your divisor, you're done. And so we don't end up with a constant term for our quotient. And so how we would write our final answer is, here's the quotient without a constant term, and then this is the remainder. And so our final answer would be 2x cubed plus 2x squared plus 5x. And then you're going to write plus and put the remainder over the divisor, which was x minus 1. Okay, and so anytime you're dividing by a linear, anytime your divisor is a linear, meaning degree 1, you can actually use what is called synthetic division. And we're going to use that a lot. It's a very valuable tool, and it's very fast. And so the way synthetic division works is you basically have an upside down division sign. And then what you put here is the coefficients of the dividend. And then here you're going to put the root of the divisor. Okay, so for this specific example, you still need your placeholder, the 0 placeholder. And so my dividend has coefficients 2, 3, -5, 7, but we have 0 as a placeholder for our x cubed term. And then the root of the divisor, you find that by setting your divisor equal to 0 and solving for it. And so in this case, it's 1. Okay? And so it goes really fast. Your first step is to just bring down that first number. And so I'm going to bring down the 2. And then each time you're going to multiply by this root. And so 2 times 1 is just 2. And then you're going to add you're going to add these two numbers together. So 0 plus 2 is 2. And then we're going to repeat. You're going to take 2 times the 1, and you're going to get 2. And then you're going to add the 3 and the 2 and get 5. 5 times 1 is 5. You're going to add and get 0. 0 times 1 is 0. Add and you get 7. Okay, this last number is always going to be your remainder. So I like to put a little box to box him off. Okay, and then these are the coefficients of your quotient. Okay, and so since we're dividing by a linear, you always drop the original degree by 1. And so our original degree was 4, and so drop that by 1, our quotient will be degree 3. And so our answer ends up being 2x cubed. And then we go down in descending order. So the 2 would go with x squared, then the 5 would go with x, and then 0 would be the constant term, and then our remainder of 7 would get written over the divisor, which was still the x minus 1. And so you can see we get the same answer, except synthetic division is way faster. Okay, and so going back to example 1, they did this problem using long division, but because the divisor was linear, you can use synthetic division. And so when you set up the synthetic division, I don't know what that setup is. We're going to do it the same way. We're going to collect the coefficients of the divisor or the dividend, which are 1, -3, 1, -3, 1. We're going to see if we get the same answer. And then the root of the divisor, we would set that equal to 0 and solve. And so 2. Okay. Oh. So first step is bring down that first number, and then you're going to multiply, add, multiply, add, multiply, add. So 1 times 2 is 2. Add, and you get -1. -1 times 2 is -2. Add those, you get -1. -1 times 2 is -2. Add, you get -5. -5 times 2 is -10. Add, and you get -9. That -9 is the remainder. And so we were originally working with degree 4, and so that means we have 1x cubed as our first term, minus 1x squared, minus 1x, and then minus 5. You don't have to write the ones. And then our remainder is negative, and so if you want, you can just put a minus and then put that 9 over the x minus 2 divisor. And so that matches exactly what they got by using long division. And so it's important to note that this only works if you're dividing by a linear. Here, we're dividing by a quadratic, degree 2. And so you have to use long division. And so we'll do this last one, and then I'll leave the last example. Okay, and so our setup is go ahead and write your dividend. Be careful for any missing terms. It looks like we're missing our x squared term. So I'm going to put 0x squared, and then minus 9x, and then plus 12. Okay, and then for our divisor, it's quadratic. And then only look at the first two terms. And so ask yourself, x squared times what would give me 5x4? And we need a 5, and then we need an x squared to get to the x4. And you're going to take that and multiply it by all three terms of the divisor. And so that gives me 5x squared times x squared is 5x4, just like we wanted. 5x squared times negative 3x is negative 15x cubed. Then 5x squared times 4 is 20x squared. Draw your line, change all your signs. So the first term cancels, it should always cancel. And then that leaves me with a 17x cubed, a minus 20x squared, and then just bring down the rest. Okay, and so now we're looking at the 17x cubed, asking ourselves x squared times what would get us a 17x cubed? We need a 17 and an x. And so 17x times x squared is 17x cubed. 17 times negative 3 is negative 51. And then we have x squared. And then 17x times 4 is 68 with the x. Draw your line, change all your signs, and then that leaves us with 31x squared, and then negative 77x. And then we can bring down the 12. Okay, and so now we are looking at the 31x squared. X squared times what would get us 31x squared? It's just 31. And then once you reach the constant, you know this is your last round. So this will be the last time we go through this. So 31 times x squared is 31x squared. 31 times negative 3 is negative 93x. And then 31 times 4 is 124. Draw your line. Change all your signs. The 31x squareds cancel. 93 minus 77. I can't do that in my head. 16. So we end up with 16x. And then 124, negative 124 and 12 would get us positive negative 112. Okay, and so when you're dividing by a quadratic, I'm not sure if all these numbers are exactly correct. They got a little bit bigger than I expected, but this is the process. And so whenever you're dividing by a quadratic, your remainder can be linear. And so this time we have a linear remainder. And so our final answer written with the quotient is 5x squared plus 17x plus 31. And then you still put a plus sign, and then you write your remainder over the divisor, which is x squared minus 3x plus 4. So your remainder should always be a degree smaller than the divisor. You should never have an improper fraction there for your final answer. And so for example 4, I'll go ahead and do example 4 just because there's a lot of steps. And if you don't want to watch it, you can just skip to the end. And so same setup, we're dividing by a quadratic. And so even though there's only two terms, synthetic division won't work. You must use long division. And long division is usually a last resort. If we can use synthetic division, you absolutely want to use synthetic division. And so my dividend is x cubed plus 5x squared minus 12x plus 10. We're not missing any terms, so no need for a placeholder. For the quadratic, we're missing the x term. So I'm going to put 0x so that all my terms line up. And so focusing on the first term, we have an 8x cubed, x squared times 8x would get us back to that 8x cubed. You're going to take that and multiply it by each term of the divisor. So 8x times x squared is 8x cubed. 8x times 0x is 0x squared. And 8 times negative 3 is negative 24 with the x. Draw your line. Change all your signs. The 8x cubes cancel. 5x squared minus 0 is still 5x squared. Negative 12 plus 24 is positive 12 with the x. And then we can bring down the 10. And so now we're asking ourselves, x squared times what would get us 5x squared? And that answer is just 5. So we know this is our last round. So 5 times x squared is the 5x squared we wanted. 5 times 0 is 0x. 5 times negative 3 is negative 15. Draw your line. Change all your signs. Cancel the x squareds. We have 12x. 10 plus 15 is 25. And so here's our quotient. Here's our remainder. And so we will write our final answer as 8x plus 5 plus the remainder over the divisor, which when you're writing your final answer, you don't need the placeholder. Just write exactly what it says here. And so a good multiple choice question would ask, like, which of the following is the remainder? And so 12x plus 25 would be the right answer, but 8x plus 5 would be a good distractor, but that's actually the quotient. And they're both linear, so that's why it's so tricky. And that's the remainder. And that's the divisor.